In innovation management, we learn that dominant designs are extremely important. For firms, this is one of a strategic priority, how to achieve a dominant design, how to set the stage, how to set the standards in the industry. We also know that achieving a dominant design is extremely challenging for firms. There are a lot of questions, a lot of problems that firms need to address when they try to achieve a dominant design. So throughout the S-curve of technology improvement, the S-curve of technology adoptions, so throughout these two S-curves, there will be challenges along the way for firms to achieve the dominant design. One key component of a dominant design is the dimension of value. And there are actually multiple dimensions of values. And this is what we're going to see in this video. Multiple dimensional values. When firms develop a new technology, so there will be some factors that will influence the new technology. One key factor is the standalone value of a technology. We can define this also as the utility of a technology. So what is the standalone value of a technology? A basic definition of a standalone value of a technology would be the key features of a technology, the benefits that the technology is providing to the users. If we look from the studies of Clayton Christensen, so if we look from this perspective, we can also state that the standalone utility of a new technology is the job that the new technology is doing for the users. So we can, in a way, say that customers, the users, are hiring companies to do some job. In how well these companies are doing the job, this would be the standalone utility of a technology. Multiple dimensional value, as I said, so means that there is one more factor to consider, and this additional factor is the externality value, what we define as the network value. What are the components of the network value? Primarily are three. The utility, so the standalone utility, which we have already seen. The second one is the install base. Install base means the number of users that adopted the technology. And the final one is complements. So complementary products that can be embedded, that can be plugged in our installed base. Focusing first on the technology standalone value, how can we define, how can we determine, how can we evaluate the value of a technology? So there are many ways of doing this here. The way that we are going to prioritize to determine the value of a new technology is the one proposed by Kim and Moberg, the buyer utility map. How does the buyer utility map work? So the buyer utility map will look at the circle of consumption, of purchasing and consumption of a product. So we start from the first stage, which is the purchase. The second, which is the delivery. The third, which is the use, so how people use the product that they purchase. The fourth stage is availability of supplements, so other complementary products to be used together with our main product. The fifth one is the maintenance, so this is the concept of the lifetime of a product, so all the service and maintenance that we need to perform on the product. Not all the products will require maintenance. Some, for example, automotive, do require extensive maintenance. And the final one, which is the disposal or the recycling of the product. So by using this 6 stage of a purchase and circle of consumption, we can evaluate them from the different factors. So the first factor would be the productivity. So customer productivity. So how this product is satisfying the customer productivity. Productivity is a typical operation management concept. So here we evaluate the efficiency, the efficacy, the delivery time of a product. The second dimension is the simplicity, how simple it is to buy and to use the product. The third is the convenience, so how easy it is to find the product. For example, whether the distribution network is comprehensive enough to cover all the geographical areas in the country. The risk dangers in purchasing the product, the fun and image reputation of a product and the brand, and finally the environmental friendliness, so how the product is produced, and also in terms of disposal, whether this product can be disposed without polluting too much. You can also see here in my lecture notes an example how we can apply this buyer utility map, which, just to repeat this again, is a way to evaluate the standalone value of a technology. So here in the slide, you can find an example of using the buyer utility map on the case of a car, Toyota Prius. So how we can evaluate the Toyota Prius, the standalone value of the technology of Toyota Prius by using the buyer utility map. The buyer utility map was developed originally for consumer goods. However, with some slight modification, for example, for the first factor, so the factor of productivity. So if we make some slight modification to include more granular information under the productivity, so then the buyer utility map can also be adopted for B2B products. So we have seen how to evaluate the technology standalone value, the utility of a technology. However, we still have other elements, other dimensions to consider: the installed base and the complements. So to grasp this concept better, let me give you an example coming from the smartphone industry. So in the past few years, we have seen a battle of a competition, a very fierce competition between two different technology when it comes to the operating systems of mobile phones, which is the battle of iOS developed by Apple versus Android developed by Google. So you can see that these two technologies, these two operating systems, they have clearly all the elements that we discussed earlier. So they have a utility component, they have an install base. Basically, these are the two leading operating system worldwide. So they have a very large install base. And complements. Complements are all the apps, all the games that can be utilized with this operating system. At the same time, we observe that other operating systems, for example, RIM by BlackBerry or Microsoft operating system for mobile phones. So these operating systems were not able to fully exploit the multiple dimensional value, and progressively they lost market share. And at the moment in 2022, we can even say that these two operating systems even disappear, or they are completely residual. So what can we learn from the case of complementary goods availability, of install base and technology utility, of iOS versus Android, Apple versus Google? So we can learn a few key considerations. So the first one is that whenever a new technology comes into this space, there should be clearly some additional value. And how can a new technology win in the battle for dominant design? There are basically two options. The first option, which you can see here in the slide, so the first option is that the new technology will focus specifically on the technology utility. So in this case, the technology delivers a much greater standalone value. And by doing so, as you can see, compared to the existing technology, which in the chart is depicted on the left-hand side, this technology has a marginal value which is superior to the previous technology. And the way the technology achieves this is entirely based on enhanced technology utility. However, this is not the only way to achieve this. As I said, there is also a second option. So the second option is for a new technology to only provide a marginal, better standalone value. An improvement, marginal improvement, not a radical improvement of a standalone value. However, this technology, even though provides just a slightly better technological utility, is still using the same install base and the same complementary goods availability of the existing technology. So you can see this depicted on the right-hand side of the graph. So this second technology, again, is delivering more value, but it's doing so by using the same install base and using the same complements. Another important factor to consider is that when users analyze a technology, and especially when users analyze these three dimensions of a technology, so as we say, the availability of complements, the install base, and the technological utility, so they will use basically three different perspectives. The second perspective is an actual analysis, so the actual performances delivered by the technology in terms of complements, in terms of install base, and in terms of technology utility. Then there is the behavioral analysis done by users, which may actually be different from the actual analysis, so the actual performances delivered by these technologies. This is what we define as perceived. So this is in the perception of the users. In some cases, users might be biased in a way or in another and may perceive greater advantages of a technology. Or they even may perceive the opposite. So they may perceive that the technology is not delivering so great advantages. So that's why consumer behavior is a very important discipline that complement innovation management. Professor Everett Rogers' analysis on the adoption and diffusion of innovation is also precisely based on this, on behavioral responses by users. The final point, the final dimension that users we consider is the anticipated. So the anticipated performances that the technology will deliver in terms of complements, install base, and technology utility. So here we have two scenarios. So one scenario is that the actual performances, perceived performances, and anticipated performances of a technology are all proportionated, meaning that there is no huge discrepancy between what a product actually delivers, what people think that this product deliver, and what they anticipate that the new generation will deliver. However, this is not always the case. So in some circumstances, users will have a disproportional approach to this. So they may have a bias considering either the complement availability or the install base of the technology utility. So they will feel like this is much bigger or much smaller than what it is. For example, if you are in a privileged network of people with all your friends wearing a Rolex, using iPhone and MacBook, and driving a Benz, so then you might have this bias that the install base of all these technologies is much, much greater than what actually is in reality. And companies, of course, know very well about this, know very well that they can, to an extent, take an advantage of this disproportional view made by users. This is the case of a vaporware. So what companies sometimes do is to advertise future products or advertise enhanced performances of future products. And in this way, by doing so, users will think that the install base is much greater than it actually is. And at the same time, another good outcome of this is that users will wait to make a purchase because we are expecting the next generation. So we anticipate the next generation of a product coming in. So they will wait, hold, instead of making the purchase now, and they will wait for the new generation to be released. There are also some fun stories about this. For example, gaming technologies like console for gaming in the past years, in the late 90s, in the early 2000s, they all claim to have up to 60% of the market share, which was, of course, impossible because you can't have like two companies have a market share of 60% at the same time, because then the sum will be 120%. But this is exactly an example of vaporware. So these companies adopted this very aggressive strategy to shift the perception of users and let them think that either the install base or other characteristic of their technology were actually greater than reality. So this leads to the final topic that we are going to see in the video today. So the final topic is the relationship between the dimension of value and the market share. We know that companies would like to impose their dominant design in the market, because when they do so, when they achieve so, they are also enjoying the network externalities. Think, for example, of a smartphone. New smartphone with a new operating system introduced to the market. Could be the case of Huawei, which introduced a new operating system a couple of years back due to sanction and political limitations. So imagine this case. So there is a new operating system, there is a new smartphone. This new operating system needs to grow, needs to be adopted by people, so needs to gain market share. And after reaching some sort of threshold of a market share, so then at this point, there will be complementers coming in and developing application software to be used with this new operating system. It could be 5% of market share, it could be 10%, it depends. So there is no one size fits all, so it really depends. But after a certain threshold, based on the market, the industry, the timing, a lot of different conditions, then we see that the network externalities will kick in. So the conclusion is that with a larger market share, then also the value will increase. And this is the case which you can see here, the graph which is called as graph A. We also have graph B. What story does graph B tell us? So the story that graph B tells us is that in case we have enhanced, a higher, a greater technology utility, the standalone value of a technology, this will automatically shift our value curve up. So we require different conditions to be met in case there is a new technology coming in and bringing a higher, a greater technology utility. Generally, the assumption is that the greater the market share, the greater the value. So we can see here some examples of this. So we have like two technologies in the graph on the left-hand side, technology B and technology A. What do we learn from this graph? So what we learn here is that there is an indifferent point, 50% versus 50% of market share, meaning that when the two technologies, A and B, each of them is owning 50% of a market share, so there is an indifference. People, users, are not encouraged to adopt either of them, so they are indifferent. However, what the graph tells us is that when either of them, either A or B, exceeds the market share of 50%, so in that case, users will prefer this technology due to the higher user base. The graph on the right-hand side tells us a slightly different story. So that graph, as you can see, technology B has higher value. So with technology B having a higher value, also the requirement of market share changes. And so what we learn from this is that whenever there is a higher standalone technology utility, for that technology to be the one widely adopted, to be the one winning the battle for a dominant standard, it needs less market share. In this example, the market share will be 60-40. Final case that we need to consider is that some technologies actually don't follow neither of the two paths that we just examined. So for some technology, they actually need less market share to capture value. So they are not compelled to reach a dominant position in the market. In the first example I gave you was over 50%. In the second example was lower, but only because the standalone technology utility was higher. But then in this third example, we see that there are actually two technologies, and these two technologies are fine even though they are not reaching a dominant position in the market. They are already capturing enough value even though they are not reaching this dominant position. So this is because the next externality value are already achieved at lower level of market share. And in this case, we can actually have more than one design, more than one dominant designs. Again, to give you an example, this is the case of gaming, industry gaming console. There are many gaming console. There are users, fan that like any of this gaming console. They don't need to achieve a dominant position to be actually enjoying the externality, the positive network externality. What are you going to take away from this video? So are two very important components. So for a technology to achieve a dominant position, they need the standalone value and they need this positive effect of the externalities. The standalone value can be determined, can be analyzed through a matrix, the Bayer utility map. And to fully assess the value, the multiple dimensional value delivered by new technology, you need to consider these three key factors: the technology utility, the install base, and complementary goods. Thank you for listening. See you in the next video. Bye.